So in this video, I'm going to go through problem set 1 and the solutions there. I've graded it just now and everyone turned it in, which is great. Everybody mostly did a pretty good job. There are some fine detail here to think about, okay? So for the first problem here, it's asking if you're asking to solve the searching problem for a list of n numbers, okay? What a lot of you didn't answer and lost some points is this next part. How can you take advantage of the fact that the list is known to be sorted, okay? So that's really one of the keys there, okay? So let's think about this. We have two different answers here. So I guess we could call this A if it's an array, okay? If it's an array, so in this case, we can get directly to all of the members, okay? So let's just have something here, it doesn't matter. 1, 4, 6, 8, 10, okay? If that's our example array, we know that it's sorted, okay? Whatever we're searching for, we can do what's called a binary search. We'll talk about that later. And it basically means you go to the middle element, okay? So let's say I'm going to do a search, if I could type, a search for 3, okay? I'm going to start by going to this middle position, 6, okay? Because I know the list is sorted, if 3 exists, it exists to the left, okay? So I can immediately get rid of 8 and 10 for consideration, as well as the 6, okay? I would then search again on the 4, and then eventually I would find it, but I would do it in 3 times instead of having to do it all of the elements, okay? So that's the advantage here. So I would just say something like, and many of you did, something like, if the list sorted, binary search, start element, and eliminate, if you spell eliminate correctly, eliminate half of the elements at each step, okay? So that would be enough for that, okay? And then B, we're looking for a linked list. Okay. Let me put this over to my poorly drawn mouse drawings. I keep forgetting to bring home my iPad with me. Okay, so if we have a linked list, okay, let's put 5 out here so we don't waste our whole day with me drawing crappy stuff on Zoom. Okay, so we've got 1, 3, 7, 8, 12, let's say, okay? And we have our connections between them. I know the textbook you used for data structures tends to do the linked list, draw them as horizontal boxes, but it doesn't matter, okay? So we've got our list to, whatever you call it, link or list, whatever you call it, okay? So the point is, if it's sorted, we can't go to the middle, right? There's no idea of middle. All we know is where the head is, basically, or the root, whichever one you're going to call it, okay? But what we can do, what it will do, again, if I'm searching for 6, okay, I start here. I would set some temporary pointer to here, or current, whatever you want to call it, okay? Is this what I'm looking for? No. So now I'm going to move to here. Is that what I'm looking for? No. Okay, but what I'm also checking, is this bigger than what I'm looking for? Okay, if it is, I'm done. So at this point, I would go to where it's pointing to the 7, you know, by letting p is equal to p link. Okay, and at this point, I check this and see not only is it not it, but it's too big. Okay, so I know it can't be to the further down, you know, the list. Okay, so it doesn't allow the binary search. It's not as efficient. It just allows us to stop sooner, basically, okay? So I would say something like this: if the linked list is sorted, I would say here, actually, that's not list, that's array. If the array is sorted, okay. So if the linked list is sorted, we will be able to stop searching, encounter a node where info is larger than the key value we are searching for. Okay, and that's really all there is for that one. Okay, so that you can do more. You can draw pictures, and some of you did, but that's the basic idea there. Okay, I think most people got the second one correct. I don't think anybody had any issue with that. Okay, and just to show again, a lot of you drew it, which makes more sense. But in the first case, you have an A on the stack. In the second case, you have the B now becomes the first element of the stack. I guess that's the point to make there. Okay. In the third case, if you pop, then you're back just to A. If you push a C, you would then have that. Okay. If you push a D, D goes to the top. The C gets pushed down one. And then finally, the A would be at the bottom. Okay. One more pop would give you a C and an A. Okay. I think most people had that correct. Okay. Okay. So the last one, lots of variations here. Interestingly enough, when I saw this problem, there were a couple of you that solved it. It turned out to be a more complicated way. That's how I would have done it, because I just didn't see it the simpler way, which is unusual. Usually the longer you've done something, the more efficient, but this one just didn't hit me right. So many of you correctly checked to see if the links were the same, because if the links aren't the same, they can't be an anagram. Okay, so that's correct. Okay, so algorithm, I don't know, is anagram, something like that. Okay, of, let's say it's going to take a string 1, string 2, okay, something like that. Okay, and then we could further have that our the input, oh, it's just what does it do? Okay, it determines if S1 and S2 are anagrams, not nanograms, anagrams. Okay, so we then have our input be 2 strings. Okay, and you could, if you wanted, I mean, you're right, the algorithm, it's legit when you're defining the input here. You could say here's 2 strings that are the same length. If you want to do that, that's fine. Okay. Output true if S1 and S2 are anagrams, false otherwise. Okay, so we can start with a basic if statement. Okay, so we can say if the length of S1 is equal to the length of S2. Okay, and again, in pseudocode, we don't have to use 2 equals because we use the left arrow for assignment. Okay, then we could say return false. Okay, once we've done that, we could do if sorted S1 is equal to sorted S2, then get my lines going there, return true, else return false. Okay, and that should do it. I mean, that's the idea of pseudocode. Okay, some of you did Python code. That's okay at this point. I want us to work toward the pseudocode because the pseudocode is less ambiguous with the equal signs and things like that. Okay. So yeah, this would make sense. Again, what I would have done, which is what some of you did, would be to count up how many A's there are, how many B's there are, and see if they have the same number of letters, which is much more complicated. Okay. So whoever, those of you who figured out the sort, good for you. Okay. So that's the problem set 1. Okay. So if anyone has any questions about that, so just save this in case anybody needs to see it later. So anyway, that's what I've got. If you have questions, let me know.